Welcome to the SolidCAM Professor video series called Jumpstart, the easy way to get started with SolidCAM. In this video, we will be going through part 3 of our first lesson, where we will add a profile operation to our CAM part, run through our workflow in the operation dialog, and simulate our toolpath. Here we have our defined CAM part with a face milling operation from the previous videos. Let's begin by adding a profile operation to machine the outside dimensions of our part. Again, we'll right-click on Operations in the SolidCAM Manager, highlight Add Operation, and select Profile. When our Profile Operation dialog opens, you will notice the workflow is very similar to what we saw when creating our face milling operation. We'll start off with defining our geometry. Click on the New button. When the Geometry Edit dialog appears, select a chain that runs around the perimeter of the part in the SOLIDWORKS graphics area, as shown here. There are multiple options available to us when defining our geometry, and we'll discuss 2 of these options in this example. The first option is to start by selecting the initial edge, then, one at a time, click and highlight all subsequent edges until we have worked our way around back to the beginning to close the chain. Take notice when we selected our first edge, this red arrow appears. This arrow represents machining direction, and you should be aware of whether you want to perform a conventional or climb cut. For this example, we will be climb cutting since SolidCAM mills on the left side of the geometry selection by default, as we'll see when we reach the technology branch. Also, the point where the mouse arrow is sitting when we select the first edge will be the initial XY position in our G-code. This gives us control over where we would like our profile machining to begin. Now, we can take a look at our second option of chain selection, Auto Constant Z. First, we will need to reject our initial chain by clicking the red X under the chain list. Now, let's start again by clicking the top edge of our target model in the SolidWorks graphics area. Then, using the Geometry Edit dialog on the left, select Auto Constant Z and click Yes to accept the selection. Auto Constant Z will close the chain by automatically selecting all connecting entities on the same Z level. With one easy step, we were able to create this entire chain. Our geometry is now defined and is displayed in the chain list as Chain 1. Our toolpath will work around this geometry. Let's click OK to exit the Geometry Edit dialog. Next, we need to create our tool. Once in our Tool dialog, let's click Select. The only tool we have defined so far is our face mill, which would not be suitable for our profile operation. So let's click on the Add Milling Tool button again and choose an end mill from the Milling Tools list. For this operation, we will use the default values, which provide us with a 6 mm diameter tool. We can also add a tool holder to our end mill by clicking on the Holder tab. Here, we have a series of different holders available under the Global tab. Let's grab the first choice in the list. If the tool picture display is not activated, click on the Show Tool button at the top right of the dialog. You'll notice if we hold and drag our mouse over the display, we can view the tool and tool holder in 3D. Any changes we make to the tool are updated visually in real time and can be viewed on the fly. For example, we can see that our tool is extending out of the holder quite a bit. Let's go back to the Topology tab and decrease the outside holder length to 40 mm. We can see that the tool picture has been updated. Once satisfied with our settings, let's click Select to exit the tool table. With the tool now defined, let's move on to the Levels branch. We'll again pick our levels right off the model. Simply click the Upper Level button. Then we can pick the feature that represents our upper level. Select the top face of our target model in the SolidWorks graphics area, then click OK to accept. Next, we'll click Profile Depth and simply pick the feature off the model that represents the profile depth. In this case, let's select the bottom edge of our model as shown here. Click OK to accept the selection. Under the milling levels, Delta Depth is available to control profile depth even further. For example, Let's say we wanted to leave an extra 0.5 millimeters at the bottom of our part. Enter 0.5 millimeters in this delta field and our tool will feed in the z-axis 0.5 millimeters short of our profile depth. Conversely, we can enter negative 0.5 millimeters and our tool will feed 0.5 millimeters past our profile depth. The direction of the delta depth measurement is represented by the arrows next to the input field text box, with a corresponding positive or negative symbol. It is also represented graphically here on the left. Let's set it back to 0 for this example. Next up is our technology branch, and we'll start with the Modify section. Tool side controls what side of our selected geometry we will mill on, and our choices are right, left, and center. We will use the default selection, left. The compensation box handles whether or not we want to use cutter compensation when we output our G-code. Under depth type, we also have 3 options: constant, define, and helical. The selected strategies are represented graphically in the lower left corner of the operation dialog. Let's use the default selection, constant. If we put a check in our rough option, we can do both a rough and finish pass. We can leave material on our wall and floor, then have the tool come back and machine off the excess material. In this case, let's make our wall offset 0.24 millimeters. Let's input a step-down value of 3 millimeters, half the tool diameter. We will leave the number of passes for our finish cut at 1, meaning our tool will come down to the full profile depth and remove the 0.24 millimeter offset on the wall in a single pass. Lastly, we will move on to the link branch. This controls how we would like our cutting tool to enter and exit the cut. Let's click on the drop-down menu under Lead In. You'll notice we have 6 available options. Whatever option we select, the diagram on the left shows us visually how the tool will lead into the cut. For this example, we will select an arc lead in and will set the radius value to 4 millimeters. This means our tool will make a 4 millimeter arc into our profile cut. Now, we have the same options available to us under Lead Out. To simplify our selection, let's check the Same As Lead In box, so our Lead Out type will be the same as our Lead In. It will set the radius value to match, 4 millimeters in this instance. Now, let's click Save and Calculate to add this profile operation to the CAM tree and calculate the tool path. Now that our profile operation is calculated, let's simulate our toolpath by clicking Simulate. We will look at our simulation in the Solid Verify mode. Since we used Solid Verify last when viewing our face milling operation toolpath, it will open as the default instead of HostCAD. Let's view our simulation by clicking on the Single Step Mode button. We can watch the tool approach the solid stock material, complete with holder, and lead into our profile cut. As we continue through, we see it makes 3 profile passes around our part and then comes back in to perform the final finish pass. Let's close the simulation and profile operation dialogues by selecting Exit for both. And this concludes part 3 of our first lesson in the SolidCAM Jumpstart series, where we've added a profile operation to our CAM part, ran through our workflow in the operation dialog, and simulated our toolpath. Thanks again for watching. Please join us for part 4 of our first lesson, where we will add a pocket operation to our CAM part, again go through the operation dialog, and simulate our toolpath.